Greetings and salutations, everyone. I speak to you
Hello.
from a beautifully empty classroom today. Apparently, the rain has made everyone stay at home. And I can't blame you. Okay. I'm sharing my screen. Can everyone see it?
I can, yeah.
Yes. Yes.
Okay, perfect. So our agenda for today is to go over the test, some of the things that people had difficulty with. Then, so we're going to have test. Then I'm going to go over the relations again in the web project, so you have some idea of what's going on there. And a few CSS highlights, but I think the book does a very nice job. So, especially with guidance for the project, for the web project. So one thing I am going to be trying to do the rest of the semester is give you guidance on the web project, because I know it can be kind of overwhelming and I have to use examples anyhow. So using examples from the web project tend to, I think, be the most helpful. So I will be doing that. And as I say, I'm not going to go through with CSS a blow-by-blow account of everything you can do, because there's just so much that I can't cover it in an entire lecture. And quite frankly, the book does an outstanding job of giving you the most important CSS properties that you're going to be dealing with. So I'm going to probably deal more with generalities and some important things that I feel the book didn't cover, and go from there. So let's first start with the exam. Okay, so most of you did well on the queries. I am not, actually, the one thing I did get a fair amount of on the queries is on the aggregation ones. I will just show, I know everyone saw different questions. There were 3 different sets of questions, but there were 2 common mistakes. One was on aggregation, and the common mistake on aggregation was doing a join with an unnecessary relation. So here, whoops, this isn't the one I want. That's not an aggregation one. Here we go. So print all clinics that have more than 10 staff on that date. For each clinic, you only need to print the clinic number, not the clinic name, not the clinic address, not the names of the staff. So it turns out staffing by itself can be used to satisfy the query. You simply group by the clinic number. That will give you your staff count, and you print that information up in the select statement. But many of you did a join with clinic, which was unnecessary, because, and then with your join, what you were doing was you were saying, you would say select C dot clinic number from staffing natural join staffing. I'm sorry, natural join clinic. But the problem is staffing has the clinic number. You don't need to go to the clinic relation to get the clinic number. Staffing had the clinic number. So this was the common mistake, and I saw it on other aggregation ones too. For some of you, it was asking for number of patients, and you would again do a join with the patient relation to get the patient number, but the patient number was already available in the appointment relation, which is what you needed to satisfy it. So when you're dealing with aggregation, you generally only need one table. You don't normally need to join with multiple tables. So I deducted a point for that because yes, correct, but it's not the right way to do it. And it's just like in English, you don't get a perfect score just for making a correct argument. There's also style and how well organized it is. So you shouldn't be overcomplicating it. Then with the relational calculus, the only real confusion I saw was that people were forgetting the mantra that in the relational calculus, if a variable is free, if it has attributes that are printed, and must be bound otherwise. With there exists or for all. So and its attributes are printed if it appears on the left-hand side. So if I say, for example, p.name, and I have, then it's got printed attributes and it is a free variable. If I now, though, have to do a join with something, say like the medical records, I'm not printing anything from the medical records, so I have to bind the medical record. And many of you were failing to do the bind like that. So that was the thing there. And again, I didn't deduct a lot of points, but I just wanted to make sure that you understood with the relational calculus, free variables are those that have some attributes that are printed. Any other variable must be bound with a there exists or for all. Okay, questions about that? Okay, moving on. Most of you got these question 2, but we'll just quickly cover them. So which of the following attributes in the appointment database would be the best candidate for a cluster index? So it's no good to cluster typically on an artificial key. So patient number is an artificial key in appointment, and staff number is an artificial key in staffing. In patient, address just isn't good because you use a cluster index for range queries, and it's just not, there's no real way to write a range query on patient address. So appointment date, that's a good one. You may often want to ask what patients are coming in between 3/1 and 3/10. In fact, a bunch of my queries did exactly that. They were asking you about a range of dates. So appointment is a good possibility. Another good possibility is group description, because even though there's no range, you could argue that, well, actually description is too big. I take it back. No, I was thinking there's only a few groups, so somehow that might work, but no, because the description is too big. It's a large text string. The other problem is group is too small to index. I told you, I think that there's only like 20 groups. Let's see. Down at the bottom, oh shoot, don't have it here. Do have it in the midterm at the bottom. I told you that there are roughly 15 groups. That means they all fit in one relation. So there's no reason to put an index on anything in group. So the right answer there was appointment date. Now I'm going to stick here for a minute because the next question said, which relations should not have any indices on them? And the answer is any relation that has at most 2 blocks required to store the tuples in the relation. So I told you that group has only about 15. That should fit on 1 block. I said there are roughly 50 clinics. And if you look at the information about a clinic, you should realize those tuples aren't very large. So that doesn't need to be indexed. And I told you that there are roughly 5 vaccines. Again, that should fit on 1 block. Okay? Whereas I said that with patients, there are hundreds of thousands of patients. That's not a good candidate for no indices. There's just way too many of them. Okay? Thousands of staff, same thing. It makes it clear you're not going to get them onto a couple blocks. Staffing. Well, there is thousands of staff, and there's many days on which we're going to be scheduling. So you can probably bet that even though there's only 50 clinics, when you multiply it by a whole bunch of staff and a whole bunch of days, that gets to be a pretty big number. It's not going to fit on a couple blocks. Okay, there are hundreds of thousands of appointments, so that's not a good one. And medical record maintains a record of which vaccines were administered to which patients. Maximum of 2 shots, but I told you there's hundreds of thousands of patients, so there's going to be hundreds of thousands of medical records, so they're not a good candidate. So there were 3 good candidates: groups, clinics, vaccines. Those would fit on a couple blocks, since clinic, vaccine, and group were your 3 choices here. Okay, on the ER diagrams, almost everyone got them right, so I'm not going to go further into them. Move on instead into normalization. And there, you were given a number of functional dependencies. You were asked about anomalies, what type of dependency they were, and then you were asked to break it down into third normal form. And this one, I think, is where most people lost the most points, at least on a proportional basis. So let's just go through these. If you delete the last order associated with a product, you lose all information associated with that product. That is a delete anomaly. This relation that I gave you for this company had multiple entities in it. It had a warehouse in it, products in it, customers in it, I think service reps in it. So deleting information about a product could cause you to lose all information associated with that entity. It's a classic example of a delete anomaly. The next one is not. So it says you cannot delete a warehouse unless you have deleted all products associated with that warehouse. That's not a delete anomaly. There's no anomaly here. This is like a foreign key constraint that says delete foreign key cascade, delete restrict, meaning you can't delete the warehouse unless you've deleted all products associated with that warehouse. So far from it being an anomaly, it's actually something that can be pretty desirable, something that you would often specify as a restrict clause when you have a foreign key. You would say on delete restrict. So nothing wrong with B. In fact, probably want that kind of restriction in place. Okay, next, if you change a customer's number, you must change every instance of that customer's number. Well, customer number is a primary key. You can't have, by definition, an anomaly on a primary key. Okay, you can't help but repeat it, okay, as a foreign key. So yes, it is true that if you change a customer's number, you must change every instance of that customer's number, but there's nothing you can do to stop that problem. It's not considered a modification anomaly. Okay, you don't have modification anomalies on keys. Okay, you cannot enter a new warehouse unless it has an order associated with it. Yes, this is an insert anomaly. Okay, the problem is you would like to be able to enter a warehouse before products have been stored there, like after it's been built, but before it goes operational. But the way that relation is set up, unless you have an order, you cannot enter a new warehouse because it requires a customer number. The primary key I gave to you is customer number and a date ordered and time ordered. So this is an insert anomaly. If you change a product's name, you must change every instance of that product's name or you'll have an inconsistency. Yes, that is a modification anomaly. So the issue with that is it's a descriptive attribute. It's not a key attribute. It's a descriptive attribute, and you don't want to have that redundant information in the database. So it's a modification anomaly. If you change the day or time of an order, you must change every instance of that day or time or you'll have an inconsistency. Not a problem because it's part of the primary key. In fact, it should be essentially only one tuple should have presumably that date, well, with that customer number, but you're changing the day and time with a specific order. That order is in your database only one time. So there is only one tuple associated with it. Changing it won't create any inconsistency. There's no other tuple in the database. Okay, that has to be changed. Finally, if you change a service rep's number, you must change every instance of that number. Again, service rep is a key. It's a primary key for service rep. It's not a anomaly. You're not going to be able to eliminate that anomaly with normalization. Okay, it's a key. So that, as I said, this one gave y'all fits. So the basic premise is, again, is that insert and delete anomalies are associated with entities. And a modification anomaly is associated with descriptive attributes. Not attributes that are part of a key. Okay, that's the general principle. Okay. So next part, I know I had to break these down into questions on Canvas. When I wrote the exam, I wrote it as a multi-part problem. So then I asked you to categorize each of the dependencies as a partial, transitive, or candidate or primary key dependency, which means it's not used in the decomposition. So it turned out the only primary key one, I told you the primary key was customer number, date ordered, and time ordered. So this one was your primary or candidate key dependency. Then for something to be a partial dependency, the left-hand side must be a subset of the left-hand side attributes. So this one has a subset of the left-hand side attributes and is a partial dependency. This one has a subset of the left-hand side attributes and is a partial dependency. Everything else, these ones, are all transitive dependencies. Okay, generally, but not always, transitive dependencies are things associated with entities. So in each case, now I know where many of you went wrong. Many of you started saying, okay, these are primary key dependencies, but they're not, because they are not the primary key in the original relation. Okay, the primary key was customer number, date ordered, and time ordered. So these left-hand sides were not primary keys. They were simply transitive dependencies in that original relation. Okay, so the order would generally determine the product number, the warehouse number, the service rep number, and then they in turn determine all these other attributes. That's why they're a transitive dependency. Okay, customer number is not determining those attributes. It is these left-hand side attributes, hence transitive dependency. Okay, now in C, I intentionally didn't ask you to show me how you broke it down. I just wanted to see if you could get the relations into third normal form using the dependencies that you were given. Okay, so the way we get these different things are as follows. So first of all, the customer number determines that information. So here's our customer relation. That comes from the first functional dependency. Then we have the customer number and the date ordered determine the service rep. So I called it order handling. Some other people had things like rep assigned, order fulfillment. Those were good names. But order handling comes from this functional dependency right here. And in fact, would have occurred when you move to second normal form. Okay, then the product, warehouse, warehouse, inventory, all come from these transitive dependencies: product number, warehouse number, service rep number. So that determines the product, the warehouse, and the service rep all come from those. Then this one right here is a double one with both warehouse and product, and is basically giving you inventory. So some of you forgot this and dropped the quantity available completely out of the original relation. But this one is also a transitive dependency, and it comes down here in inventory. That leaves one more, which I call transaction details, but order items is probably better. Some people called it shipment details or product shipped. Those were all good names. Where did this come from? It did not come from any of the decompositions. Okay, and transaction details is a multi-valued attribute. And in the original problem, I told you it was a multi-valued attribute. So, or at least I believe I did. Let's see, blah, blah, blah. Okay, I'm not sure if I told you that or not, but it is a multi-valued attribute. Okay, so what it's doing is it's giving you multiple details about the items that are ordered. So in fact, you would get this transaction details, when you went from unnormalized form to first normal form. Okay, so that's where that one is coming from. And finally, orders is essentially what is left when you have decomposed everything. And in fact, you see it essentially is this candidate key dependency or primary key dependency with the order items effectively removed. And I did have to add a order number just to make it easy to access, to tie items in the order items back to the original order. Okay, so that's where these relations came from. Any questions about any of this? Okay. Moving on. With the ER diagrams, y'all did quite well on this problem. I was pleasantly surprised. So the entities were patient, clinic, staff, and vaccine. And the relations were staffing, appointment, and medical record. So you had staff works at clinic, and you got that from the staffing relation. That gave you which staff worked at which clinic. You have group contains patient, and you did not have to have this relation if you did not say that group was an entity. Technically, group is an attribute. It is not an entity. You could have easily listed that information with a patient, but I was fine if you represented it as an entity. I can certainly see why a good argument for representing it as an entity. I have no quibbles with it being an entity. So this was an optional relationship because you didn't have to have it if you did not have group. If you decided that group was an entity, you had to have it because the patient has a group number. So group contains patient. Then the appointment gave the patients who have made an appointment at a clinic. So a clinic services patients, or a patient makes an appointment at a clinic. Both of them find ways to express that relationship. And finally, with the medical record, it's a three-way relationship between the patient, a vaccine, and a staff who administers it. So it should be staff administers vaccine to patient. If you put medical record there, I'm fine, you got full credit. But it was medical record is a ternary relationship between staff, patient, and vaccine. Okay. You would get partial credit. Some of you represented this medical record as two different binary relations where you said patient gets vaccine and staff administers vaccine. You'd get half credit for that. With appointment, some of you had it as an entity with clinic has appointments, patients make appointments. So you use two binary relationships with appointment as an entity. So you lost 2 to 3 points on that, depending on how egregious the mistake was. Questions about that one? Okay. MongoDB, what I got from that one is I made the problem too easy. Almost everyone, this was easily the problem that had the fewest number of deductions. So this was definitely good. I gave you partial credit on 1 and 3 if you got all but one of them. You got a point if you got all but one of them. Finally, 8, I was asking you for functional dependencies, and they pretty closely mirror the assumptions up here. So a reservation with the same flight number always has the same departure and arrival airports regardless of the day. So that means the flight number determines the departure and arrival airports. You get that from A. Each day, a flight number might have a different departure time, gate, and arrival time, and a different plane flying the route. So that means that a flight and a date determine departure time and gate, arrival time and gate, and aircraft number. A seat may have a different price on each day on which a flight occurs. Therefore, a flight, a date, and a seat determines a ticket price. And I was fine with that. You got full credit for saying that. It also, as a matter of fact, determines the customer number, which I had not stated, but which some of you figured out. Okay, so it also uniquely determines the customer number. Okay, so then we have a flight number only goes once each day. And that was meant to mean a couple things, that the customer number, the flight number, and the date would get you a unique seat number. Okay, now you have to combine that with some other information. So we have seats are never double booked on any flights. Customers may not have more than one seat on any flight. Okay, so if you combine that information with D, so a customer may not have more than one seat on any flight, and the flight number goes only once each day. From that, you can deduce that a customer number, a flight number, and a date will give you the seat number at which that customer sat. Now, many of you also put ticket price here, and I have no problem with you saying ticket price there, but it's not really, the customer number actually is not determining the ticket price. It's actually this portion plus the seat number that is determining the ticket price. So technically, you really shouldn't have ticket price here on the right-hand side. Yes, it is true that the customer number, the flight number, and the date determines the ticket price, but only because the flight number, date, and seat number determine the ticket price. So the real functional dependency for ticket price was right here. That is what really determines the ticket price. Okay, to give you another insight onto why it's shaky to put ticket price here, customer number could be null for a particular seat. Seats can be unassigned for a flight. Okay, that's a problem then, because how do you determine the seat's price from the customer number if it's unoccupied? So that's another kind of tip-off that it's a little dubious to have the ticket price right here. Again, I accepted it, did not deduct points. I'm just trying to explain why it's dubious to have ticket price in addition to seat number here. Okay. Then let's see. A customer is allowed to have multiple reservations per day since they might have multiple flights. So for example, you couldn't just say that the customer number and the seat number determine the flight number, because the customer is allowed to have multiple flights on the same day. And there may be multiple flights on any given day. So multiple flights out of the same airport to the same airport. So you can't say things like departure airport and arrival airport determine a flight, because you could have multiple flights going to those airports. Okay. So this just explains what I just said with customer number, flight number, and date. And that I was okay if you omitted the customer number, especially because the customer number might be null, but it really did determine the customer number. Finally, one person found this dependencies, and I was really impressed. I didn't find them either, and I didn't expect you define them. So the date, the departure time, the departure airport, and the departure gate does uniquely determine the flight number, the arrival time. So it uniquely determines the flight number, which in turn, with the date, gets you these other attributes. So this was very clever. It is the case that knowing the date, the departure time, the departure airport, and the departure gate, now that does uniquely determine the flight number, the arrival time, and the arrival airport, and vice versa. The date and the arrival time, the arrival airport, and arrival gate uniquely determines the flight. So one person got that. I was impressed. I did not get it, but those are definitely valid functional dependencies. Okay, because we did not do the binary search tree, I'm not going to go over it. Wow, that's, let's see. This is the one I wanted you to work on. It is not the one that got uploaded to the exam. What I wanted to have happen, whoops, even this one is not, nope, this isn't the right. 150 to the leaf, there is no, okay, this wasn't the right binary search tree. That's why the wrong one got uploaded. Okay, so now I see why the wrong binary search tree was there. It was also in the original exam the wrong way. Okay, so that pretty much wraps it up for the exam. There's no final, so your web project will determine the grade for the web programming portion of the course. You still have to do a bunch of stuff with databases in the web project. So that's what I wanted to turn to next. So any questions about what I went over with the midterm? Okay. By the way, this is the binary tree I wanted. Finally, I found the binary tree I actually wanted. Okay. Okay, so let's look at the database relations. Someone did have a question, they just unmuted, or no?
I have a question about the web project.
Go ahead.
If we're working with somebody, do we only have to turn in one zip file for both of us?
Thank you. If you're working with someone, please only turn in one file, and in the submission comments indicate who you're working with. Thank you. Yes. Just one submission, and in that submission indicate who your partner is. And again, if you're a graduate student, you can't do that. Only undergraduates get to work with other people. Other questions about that before I go into the database portion? Okay. So that's not it. There we go. Okay, so most of these are self-explanatory, but I kind of want to go over how things are happening. So in the web interface, what happens is someone logs in. Okay, so there's kind of this thing in the web project. The interaction is a user logs in. And to do that, they need to provide an email and a password. And if that succeeds, they are taken to a screen where they have a set of courses they can choose from. and the major. So a course may be listed twice. For example, if CS360 is assessing both CS majors and computer engineering majors, then it will appear twice in that menu. Once as showing, it would be something like, it would show up as maybe COSC 360 fall 2019 CS, and it would show up a second time as COSC 360 fall 2019 CPE. So it'd show up twice because the professor has to enter assessments once for CS students, once for computer engineering students. So the first query I'm asking you to do in the homework assignment is a query you'll have to execute in order to locate this information. So if you go and you look at the database relations, you can see that the instructor relation has the email and the password. So that's what you're verifying the email and the password against. Now you can see that these sections have a instructor ID and the course ID, the semester and the year. So that gives you the courses taught by the instructor. So once you have the email and the password, you can get the instructor ID. And if you go down to section, you can see that you can find the sections that the professor taught. But the problem is, it doesn't give you the majors that were taught in those sections. So you have to figure out where you can come up with the majors. And the key insight is that we have a course outcome mapping, which maps course IDs, semester and years to a major. So once you know the course that the instructor taught for that semester and year, you can determine the majors that were taught in that course from this relation. So you see, once you have the section, that gives you the course ID, the semester and the year, and you can use that as a foreign key into course outcome mapping to get the majors. So that will give you the result you need for the first question, which is the first question was print the instructor ID, section ID, course ID, major, semester, blah, blah, blah. But that's what was going on, okay, is you're getting that information with this query. Now, you will get multiple results because when you hit course outcome mappings, because if it has evaluated multiple outcome IDs, you'll get the same course returned multiple times, once for each outcome ID. So you need to use select distinct to get rid of your duplicate tuples. That's why some of you are coming up with multiple instances of the same tuple. What you're not seeing is that you're projecting out the outcome ID, and the outcome ID is what was actually making the result unique. But because you're not printing the outcome ID in your output, you're seeing what appears to be multiple duplicate tuples. They're not really duplicates because the outcome ID was different for each of them. Okay, so now once you have the menus, the next thing the instructor can do is the instructor selects a course to assess. Okay, and that's going to return a collection of outcomes. I know I didn't do that well, so it's a collection of outcomes. So the second query that you're being asked to do on the homework says print the outcome IDs and outcome descriptions of all outcomes assessed for CS majors by section ID 3. So supposing that the instructor said, I want to assess the CS majors for whatever section is associated with section ID 3, now you may remember from the website that you do, when you select a section, it lists right here the outcomes so that the instructor can select an outcome. So query 2 is asking you to find the outcomes assessed by a section. And again, if you know the section ID, then you know your course, the semester and the year, and you at this point know your major. So with those 4 pieces of information, you can look into the course outcome mapping. And since you know the course ID, the major, the semester, and the year, you can get all of the outcome IDs that are being assessed for that major and that course. And then finally, with the outcome ID, you can locate the outcome descriptions for that major. Again, you need to know the major in order to get the outcome description for that ID. But you have that information. So that's the point of query 2. Then queries, let's see, 3, 4, and 5 are print all outcome results, assessment plans, and narrative summaries for one of the outcomes. So what happens next is the instructor selects one of these outcomes. So for example, here they've selected outcome 1, and you can see, first of all, we have to put this outcome and its description up here on the page, which is why you need that information. Then we need to know the outcome results so that we can populate these 3 numeric numbers. We need to know the assessment plans so that we can fill in that part. Just moving ahead a little bit. So we need the assessment plan so we can fill in this part. And we need the narrative summary so we can fill in the strengths, weaknesses, and actions. So queries 3 through 5, you will eventually use to initialize these 3 forms that the user is entering information into. And given that you are given the major and the section ID. Oops, I'm sorry. You're given the major, the outcome number, and the section that is doing the assessing. So it should be pretty easy for you to locate the outcome results, the assessment plans, and the narrative summary for those majors. And then the final query that I'm having you do is an aggregation one, just to give you some practice with aggregation. So the sum of the assessment plans, the weights, has to equal exactly 100. So I'm simply asking you to print out any outcome whose assessment weights do not exactly equal 100. You'll need a group by in order to do this. Now, in your real project, on the client side, you're actually just going to add them up. You're going to add up the weights. And if the weights don't add to 100, you'll print an error message. You actually won't leave it to the database. But I wanted to give you some more practice with doing aggregation, hence why you're doing number 6, query number 6. Okay. So Questions about that? And then finally, I'll give you a big hint for the ER diagrams. The outcome results, the assessment plans, and the narrative summaries, you can view them as either multi-valued attributes or as relations. That's your hint. You can view them either way. I'm going to accept two different ER diagrams, but the assessments, the outcome results, and the narrative summary, you can view those as either multi-valued attributes or you can view them as relationships. Okay, final thing. A lot of you are getting an issue with an error message. So when I run my ABET for the first time, it works fine. But when I run it again, I get this error message. And many of you will get this error message. It says, drop table cannot delete or update a parent row. A foreign constraint fails. What that means is the order in which you drop the tables is important. So as an example, because remember I said that your deletes, your foreign key should say on delete restrict, meaning you can't delete a row from the parent if a child refers to it. So one of the foreign key constraints you'll have is sections has a course ID. It's a foreign key constraint on courses. If you try to delete courses first and sections second, you'll get that delete error message because you're trying to delete rows from courses, which tries to propagate that delete to the sections, and the sections are saying, on delete restrict. So they're saying that deletion is denied, which means that the courses relation cannot be deleted. So you have to order it such that sections is dropped first and courses is dropped second. So that by the time you get to courses, all of its dependent sections have been dropped and MySQL will be happy then to drop the courses relation. So when you see this error message about cannot delete or update a parent row, a foreign constraint fails, that's what's happening. You have misordered your drop tables. Okay. This is actually where sometimes drawing a dependency graph can help. And then topologically ordering it. I think you went over dependency graphs, and certainly you went over topological ordering on graphs in 302, but this is an example where you have a section depends on course. So you're going to have to sort section first. If something else depends on section, you'll have to do that before section. So you can draw a dependency graph and then topologically sort it, and that gives you an order for your drop tables. Okay.
Quick question.
Yes.
The default constraint on foreign keys is the restrict, right?
I believe so, yes.
Okay.
But I want you to make it explicit.
Okay, that's what I was asking. Okay.
Yeah. Please make it explicit for me.
Dr. DZ?
Yes.
Oh, sorry.
Go ahead.
That turn in early, get extra credit thing, does that also apply to the web projects as
It
well?
sure does.
No kidding? Oh, damn.
No kidding. That's a good way to get extra credit. It applies. So you can get, I mean, this is basically an opportunity to get I think the web project's 30% of your foreign grade. So the final grade. It's a way to get an extra, effectively 3 free points added to your final grade just by handing it in early.
That's wonderful. Thank you.
Yep, you are welcome. So, yes, very much so. Other questions? Chuckling, however, probably should be muted.
There's actually a question
Yes.
for that. The graduate project too.
Mm-hmm.
That everything's 5 points
Yes.
or 5%. Okay, cool.
Yep. I want to encourage early submissions. This early submission thing is, I know as the semester gets long in the tooth, it gets harder and harder for y'all to get your projects done on time. So by giving you extra credit, what I'm trying to do is incentivize you to do good time management. I will tell you I do have a devious reason behind giving you extra credit. I'm actually trying to force you into good time management.
Well, I appreciate your deviousness.
Yep. So it's kind of, I feel like it's a win-win, right? That not only can you get extra credit, but you can also get the project done and move on to other projects and other courses. So I figure it does no harm. It just does good. Okay, other questions? Okay, I know I don't have a lot of time for cascading style sheets today, but it's honestly, this is one of the easiest lectures, and I'm more than happy to take questions, but the book does a nice job of covering CSS. So let me just quickly show you an example, and I know the book has a ton of them. So here's just a simple example of how you can style something. So if you don't do any style, I just have a paragraph. It says this is a plain paragraph with a bunch of text. Okay, and I go ahead and I display it. And there it is, a plain paragraph with a bunch of text. Okay, and often you want to do things. So for example, let's say I want to style it so that it is got colored red and its font size is 16. So CSS gives you what are called selectors, and then a block where you give a set of properties that can be layout or appearance related. So here I am saying that I want the color to be red and I want the font size to be 16 pixels. And you notice that they're separated with semicolons as the delimiter. They're essentially key value pairs. Okay, so when I whoops, I didn't save it. Now when I reload it, it is in red, and the reason it didn't change is that the default font size is 16 points. So let me change it to something bigger, because browsers by default use 16. There we go, made it bigger. Okay, so and then let's say that I don't want all of my paragraphs to be red. So this is a second paragraph. And I don't want that one to be red. I just want this one to be red. So one way I can make that happen is assign it a unique ID like first. And so now instead of saying P, I can say hashtag first. That's a selector for an ID. Whenever you say hashtag, that selects an ID. And since it's unique, so only the first paragraph shows up that way. Okay, and then there's other ways that the book gives you for identifying the first paragraph. I think I may get this wrong, unfortunately, because I don't deal with this a lot. I think you can say something like P first, I think it will also, nope. Well, I knew that I might be doing something wrong. See if that works. Nope, still wrong. Okay. There is a way to specify that it is the first paragraph, and I'm obviously not doing the selector right because I'm doing it on the fly, not from my notes, and I'm not sure if someone knows how you indicate the first.
There's a first of type
First of,
pseudo selector.
so first of type, like that.
Yes, there's also a first child if you have them nested together in a container.
Yep, very good. Well, it's still not working. What am I save it? Yeah. Well, I'm not
You have to
doing.
get rid of the space.
Pardon? Get rid of the space. Thank you. There we go. So that's yet another way to do it. So CSS gives you a plethora of ways to do selection of elements in your HTML files. So basically, there's ways that you can identify blocks of content. So ID equals is one way. Then class equals, class is not as, so ID is meant to be unique name. Class is not unique. Name that applies to a group of similar tags. So for example, another way I could have done it is every paragraph that starts a new section, I might have said class equals first. And then I might have like a heading 1, blah, blah, blah. Another heading 1, blah, blah, blah. And that paragraph would also be class equals first. So class is a name that applies to a group of similar tags, and we want them all styled similarly. And up here, the way you refer to a class is with a dot. So I would say p dot first, or I could just say dot first if I want it first to apply to all classes. If I only wanted it to apply to the paragraph class, I would put p dot. So when you're using a ID as a selector, it's a hashtag. When you're using a class as a selector, it's a dot. Okay, some other useful things for the project is you will often have to style input to be specifically look like something. And here's a way to do it with input. So you can basically select on the attribute. So here you may need to, in the where you're reporting the results and where you are assigning weights to the assessments, you have number widgets that you're going to have to do some styling for. So you can select by saying type equals number. Or here, even more specifically, a selection on the value attribute, specifically the input where I have save results. Here was one for the button save assessment. So this is how you can get really specific. Here was the trash can and doing the selection using the alt attribute. So sometimes you can use the attribute and its value to select a particular class of input. Okay, so that I just tell you right now, that will be useful for your project, being able to select specific input elements and style them. So you might want to remember that little trick. Okay, so with CSS, we basically cover appearance today and layout positioning on Tuesday. And the common ones that you change are color. So that gives the color of text. You'll often have background color. So I could say blue. Actually, that's going to go, we'll call it, what's red go well with? Not a whole lot. Yellow. So now the background is yellow. Okay, so there is a bunch of attributes that allow you to control the appearance of things. Big things that you want to often control are font, color, borders. So font, color, border. I think those are the big three, actually. Then, so that's with appearance. The big three are font, color, and border. I guess spacing comes into play too. But we'll get to that in a moment. The big three are font, color, and border, things that you want to be able to play with. Sometimes with appearance, you have width and height as well that allows you to do scaling. And there's all kinds of measures that the book talks about, and you often just have to play with it. So you can do measures in terms of pixels often, which is px, in terms of a point size, in terms of inches or centimeters. You can do it often with a percent, which increases or decreases the font size. You can do it with something called M, which is essentially the width of a character. So the book has a good description of when you use each. So I'm not really going to cover that. I tend to go a lot with pixels, px. Inches may or may not work, but pixels tend to. The problem is Windows and Mac have different resolutions. One, I think, is 1 to 72, and the other, I think, is 1 to 90. One is something like 72 pixels per inch. I think that might be Mac. I think Windows might be 96 pixels per inch. So the problem sometimes with using pixels is that it will show up differently. It'll be platform dependent. Inches should be platform independent, but I'm never sure whether browsers support that yet or whether it's only supported on printers. Someone who works in the industry might know.
Yeah, they're not very reliable.
Okay, so you can't really rely on inches and centimeters to control your width and height in a browser. Like I said, I tend to use px for pixels. It's just me, but it seems to give me a pretty good result.
Percent is definitely the normal way if you're planning on targeting multiple platforms, like you said.
Okay.
There's also two new ones called VH and VM, or VW, I mean, VH and VW, which is like one VH is 1% of the height of the view screen, and one VW is 1% of the width of the view screen.
Okay, that makes sense because that would really help. Okay, so VH is 1%. How well is that supported by browsers?
It's on every browser now.
Okay. So these are good ones, VH and VW, because yep, at 1%, they allow you to very specifically target how much of the screen you're able to see. And then this percent allows you to increase or decrease the amount of things. So for example, if I say a font size should be 200%, it will double the size of the current font. If I say 50%, it will halve the size of the current font. And it's multiplicative, so it's always applied to the current font. Then I guess the big thing is that with CSS, when you notice, these are called blocks. And the way, a big thing with CSS is how you lay out blocks. And it uses what is called a box model to lay out these blocks. So a box has a border, it has a margin around the border, Then it has padding inside the border. So this is called padding. And then it has content. Okay, and you're going to have to play with that a lot in your project. Okay, so this is called the box model. So let's just quickly play with that to show you how that works. So again, here is my paragraph. And the first thing I'm going to do is I'm going to add some padding to it. Actually, I'm going to add a border to it first. So I'm going to say p.first border. Fortunately, I always forget the order in which I specify things. I think it's black. Hope it's solid 1 pixel, but I'll probably get it wrong. Yeah, naturally I got it wrong. I certainly don't want this other stuff in there.
I think the size comes first, if I'm remembering correct.
See if that does the trick.
I don't think it's supposed to have commas between it.
Okay, that would also see. This is why I don't go over all this stuff, because it's important, but there we go. And you probably can't see that border, so we'll make it nice and fat. There we go. So nice fat border. Okay, so now let's get rid of these headers. And let's add some padding. So we'll just start with a blanket 20 pixels, which will do it in all directions. So you see it added 20 pixels in all directions. I could say just padding dash left and padding dash right, in which case I got it wrong again. Well, there's ways to specify just left and right padding.
You just have to do them on separate lines.
Okay. So is it really padding? Let's see if that works. There we go. Yep, so you just do it on separate lines. So you can control that. Then you can control the margin. So we'll add 30 pixels on the margin. Boink, you see 30 pixels. So get familiar with margin and padding. It will be, and borders, because those are your friends. Those are the things that will help you to control content and to put nice spaces and padding between things. Okay, so that is important. That pretty much covers what I wanted to cover today. Tuesday, I actually have an in-class project because we're going to actually go over a couple of the layout managers that, or layout algorithms that CSS provides, and that I think you will find helpful for doing layout of the web page for the project. So actually, we'll go over some of the layout algorithms that CSS provides. The two big ones are grid and flex. We'll go over those on Tuesday, and then you'll actually do a short in-class exercise to try to get the, basically to mimic what the appearance looks like for the ABET website. So in the ABET website, we'll cover it on Tuesday, what was going on there. So Tuesday, essentially, what we're going to be doing is looking at how we do layout using CSS. So have a good weekend. Feel free to stick around if you have questions. Happy to answer questions. Otherwise, I will see you all on Tuesday.